Before we go into transients, we will first understand what is meant by a first order circuit, what is meant by a second order circuit. So whenever there is either capacitor or either only inductor, then it is called a first order. So why that is the case? See, if you remember, the inductor and capacitor, to represent the VI relationship, we use a differential, right? So I is equal to C dV by dt, and for an inductor we have V is equal to L di by dt. Okay. Now this is what both of them are first order equations, right? You remember the order of the differential equation. What is the order of differential equation? See, if this is d of n x dt n plus some coefficient into d n minus 1 x t n minus 1 plus so on till d a n dx by dt plus a n plus 1 is equal to 0 if you take. Okay. So what is this order? This is nth order differential equation. Okay. Now here if you can see, for inductor and capacitor we have only the first order. Okay. Now what if there are two elements? That means both inductor and capacitor are present. Here you will get a second order differential equation. Okay, so whenever you apply the KVL or KCL, if it's a parallel connection, then you're going to get a second order differential equation. But in the case of only one capacitor or one inductor, okay, it can be a combination as well. See, if you take this, then you can represent by an equivalent capacitance, and still in that case also you will get a first order differential equation. Okay, so that is the difference between first order and second order. And now we are going to start with the first order equations. This is more important. Okay, second order also we will discuss, but we will not go into too much depth.